Here's worksheet has 8 questions on page 3, and I am planning to go over these 8 questions, and then you can have a go at the remaining questions. Okay, so question 1, you have to solve the following equation: 7 sine 4t plus pi over 18 equals 4 t between minus half pi up to half pi. So the first thing we're going to do is rearrange it to make sine 4t plus pi over 18 the subject. So it's sine 4t plus pi over 18 is equal to 4 over 7. So once you've got this, you can find the principal angle. But before I do that, let's just consider the values of t that you need to solve it for. So you need to times the t's by 4 and add pi over 18 to work out the range of t's for which you are solving. So if I times minus pi over 2 by 4 and add pi over 18, then I will get minus 2 pi plus pi over 18. So let's work it out. Minus 2 pi plus pi over 18. So this is going to be minus 35 over 18 pi. So it's almost minus 2 pi. Let's just work out. It's minus 6.108. There's 4t plus pi over 18. And then if I times the pi over 2 by 4 and add pi over 18, then I will have 18, 2 pi plus 1/18 of pi, so that should be 37 pi over 18, which I can do it again here. So that gives me 6.4577. So this is going to be just over 2 pi, so just over 360, and this is just past closer to 0, so minus 360. Okay, so this is, I'm expecting 4 solutions because it's been squashed 4 times. Okay, so the first thing we're going to do is do the sine inverse. So this angle here in the brackets is going to give me sine inverse of 4 over 7. This is the principal angle. You need to make sure you are in radians. Sine inverse of 4 divided by 7. That is 0.60824. The second angle, remember the sine graph looks like this. So once you've got this angle, the second angle is going to be pi minus this angle, if this is x, so pi minus x, so it's pi minus ans, which is 2.5333, etc., etc. So but obviously this is taking us up to 6 on the positive. There won't be any more on the other side, so we need to find the other 2. So to find the other 2, because we need to go down to negative values, we're going to take away 2 pi, because these 2 solutions repeat themselves every 360, so you can minus 360, which is 2 pi. So we'll do the top one first. Okay, so that gives me minus 3.7498, and the other one, I go back to this one, minus 2 pi, that gives me minus 5.6749. There you go. So I've got 4 solutions, but this is what 4t plus pi over 18 is equal to. So now I need to subtract pi over 18 from each one of those and then divide each by 4. So t will be, if I subtract pi over 18, let me start from the one that I have in the calculator. If I minus pi divided by 18, that gives me minus 5.849, and divide that one by 4. So this is minus 1.46 to 3 significant figures. That's the first value of t. The second value of t, let me just scroll back. It's quite useful that I still have some values there. Let me just do the second one as this one. So I'm going to minus pi over 18. There you go, and share it between 4, divide by 4. So the second solution, which is going to be the first positive one, 0.108 to 3 significant figures. And then we did, let's just go for this one. So that one was pi minus ans. Oh, that's wrong. It was this one, pi minus this one. There you go. So let's minus pi divided by 18 and then divide by 4. That one is 0.5897. Now hold on, so that's going to be 0.590 to 3 significant figures. And the only one I haven't done is this one. This one here is actually, if I go back to this one, that was pi minus ans, and then we took 2 pi away from that. So obviously you can just type in those digits instead of going back to the exact values. So we need to subtract pi divided by 18. There you go, and then divide by 4. So minus 0.981 to 3 significant figures. Now let's say if I wanted to check if this one is correct, one of those, so let's say minus 0.981. Obviously, if I use the exact solution from the calculator, that should give me the answer of 4 when I put it in. If I use the rounded one, then it's going to be approximately equal to 4. Let me just use the exact form. So if I do 7 sine, and then all I need to do is do 4 times ans plus pi over 18, that gives me the answer 4. So I know definitely that's right. If I want to check if this one is correct, let's say I want to put the rounded answer because I haven't got the exact answer. So I'll put it as ans and do 7 sine, oh, actually I had it typed in before, but never mind. I'll just use that plus pi over 18. Okay, that gives me a value close to 4. I reckon that is correct. And then you can just put minus 1.46 equals, if you scroll up, you still have that rule written down here. That is just above 4, so that's good enough. And then I'm not going to check the last one, I'm confident that's correct. So these are my solutions, okay? Question 2. Question 2 deals with double angle formula. So with solving equations, it actually asks you, let me just have a look. It asks you to solve it between 0 and 360. So the first thing you do in those questions, the one that has 2 theta, that's the one that needs to be changed into single angle. So we're going to use cos 2 theta, and you know that there are 3 different ways of writing cos 2 theta. You've got cos squared minus sine squared. You have 2 cos squared minus 1. And then you've got 1 minus 2 sine squared. So because the remaining function that I'm not going to touch is sine, I'm going to use the sine version. So 1 minus 2 sine squared theta. So let's replace it. You will have 3. Then 1 minus 2 sine squared theta minus 5 sine theta equals 4. Expanded, 3 minus 6 sine squared theta minus 5 sine theta equals to 4. Rearrange it. 6 sine squared theta, move everything on the right hand side, plus 5 sine theta, and the 4, 3 joins forces, 4 minus 1 is going to be 1, so plus 1 is equal to 0. That will nicely factorize. 3 sine theta, add 1, 2 sine theta, add 1 is equal to 0. So 2 solutions from the bracket. Sine theta is equal to minus 1/3, or sine theta is equal to minus a half. So let's deal with sine theta minus a half. Just a moment, let's just shut this door. Okay, so sine theta is equal to minus a half. You can use the calculator to do the sine inverse. The first angle the calculator gives you is minus 30. So you might think, well, I'm not going to use minus 30 because I need to solve between 0 and 360. But you need to find the angle that goes with this. So this is just the angle you use to find all the other solutions. So if that's your sine graph, that's minus 30. The one corresponding to minus 30 will appear over here. So 360 further along. So you can either add 360 or you can think of it as 360 minus 30, which is going to give me 300. And this one here is going to be on the other side. So this is 30 here. So that's 30 added to 180, which is 210. Okay, so this angle here is 360 minus 30, or minus 30 add 360. And this angle here is 180 add 30. So these are the two solutions from that. This one here will do sine inverse of minus 1/3. Again, you should be getting a negative angle. So let's just check the angle should be in degrees here. So do sine inverse of minus 1 divided by 3. That gives me minus 19 point, let's just round, we can round this one because we won't be dividing it, so 0.5. So this is the principal angle. Then again, the next one is going to be 360 minus 19.5. That gives me 340.5, and the other one is going to be 180. There you go. It's always 180 minus this angle, so I'm going to add the two together, so it's going to be 199.5. There you go. Again, any angle that you obtain, so if I just do 180 minus, so this is 190.47. If I wanted to put it into the original equation, will I get 4? It's worth checking. So 3 cos 2 times ans, and then minus 5 sine ans, should be getting 4. Yeah, so that is correct. So you can check the other angle. So let's have a look at question 3. So here is another example of a double angle formula involving sine. So replace your sine 2 theta with 2 sine theta cos theta. That's the formula you need to remember. Since this is in terms of sine and cos, you might as well go for changing tan in terms of sine and cos as well. Okay, so don't like fractions, let's multiply this side by cos. You'll have 2 sine theta multiplied by cos squared theta equals to sine theta. Okay, so the temptation here is to see sine theta on both sides, so let's divide through by sine theta. So you cannot do it. You have to rearrange it on one side and factorize. You cannot divide by anything that could potentially be equal to 0. So unless you solve that it's when it's equal to 0, but better to always factorize it. So let's factorize sine theta, and you'll have 2 cos squared theta minus 1 is equal to 0. So there's two terms involved in the product. That product will be equal to 0 when either sine theta is equal to 0. So this is what I was saying, unless you could potentially cancel sine theta if you have solved that equation on the side, but I wouldn't recommend it. And this one is cos squared theta is equal to 1/2. So sine theta between 0 and 180 is going to be equal to 0 when theta is 0 and 180 degrees. Cos squared theta is equal to 1/2. That generates two mini equations. Cos theta is equal to minus 1 over root 2, or cos theta is equal to 1 over root 2. So if you do cos inverse of minus 1 over root 2, let's have a look. What are you going to get? It should be a nice angle. should be 135. Let's just double check. Minus 1 over root 2, 135. There you go. Or the second solution for cos function, if you remember rightly, if that is going to be minus, that's your 135, remember that's 90. So the second one is always 360. If that's your x, 360 minus x. So if that x is 135, so it's 360 minus 135. There you go, so it's 225. Doing the same for this one, so theta here, that's going to give you 45. And then 360 minus 45, which should give you 315. There you go. Almost put 225. There you go. 4 solutions. Okay. So the next question, you've got tan squared, tan, and sec squared. So when you see tan squared and sec squared, or one of those is squared, one of those is not, you know that there is going to be an identity involved. 1 plus tan squared theta equals to sec squared theta. If it was cosec and cot, you would do 1 plus cot squared theta is equal to cosec squared theta. So the way to do it is to decide how am I going to turn it into an equation in terms of one variable, so one function, either tan or sec. So if you wanted to change everything in terms of sec, it would be a hard question to do, because you could change tan squared by using sec squared minus 1, but you would have difficulty with changing tan theta because you would have to introduce square roots. So the one that is squared and on his own, not with his little brother that's not squared, that's the one that you change. So the right hand side needs to be changed to 1 plus tan squared theta. And now it becomes hidden quadratic. So tan squared minus tan is 1 tan squared. You can introduce the dummy variable if you prefer. So maybe for this one I'll do so. So let tan theta equal to y. So you've got y squared plus 4y plus 5 equals 0. It allows you to see the quadratic easily. So this one will factorize, will it? No, it won't. So we are going to hold on a second. I forgot about the 1 here. That was 1 minus 1. That looks like it's 4. Yeah, I thought it looked. So this one actually is a perfect square. Y plus 2 all squared is equal to 0. Give me y is minus 2. But y is tan theta, so you've got tan theta is equal to minus 2. So theta is equal to tan inverse of minus 2. So we are in degrees, and in degrees, minus 2. Oh. So the answer is the principal angle that you're going to use to find the other solutions is minus 63.4. So to find the other solutions, remember tan repeats itself every 180. Do not need to draw tan, but I'll just remind you that what it looks like, this is 180 and this is 360. So that's what it looks like. Okay, so if you've got this angle of minus 63.4, so he'll have a matching brother over here, which is 180 degrees away, and another matching brother over here. So you just need to add 180 twice. So you should know for tan, to find the other solutions, just keep on adding or taking away 180 degrees until you find the values that fall in between, in the range that's required. There you go. So these are our thetas as a final solution. Right, so moving on to question 5. So over here in this question, I just need to answer the question. Okay, we're asked to do 4 things with this function. So this is what you could be asking the cos or in our sine questions. So the first thing, it asks you to find the minimum maximum value of this function. So the minimum value and the maximum value. So this is simply sine that's been multiplied by root 15. So sine graph, if you draw sine, it looks like this. That's not if it's been shifted by pi over 3. If it's been shifted by pi over 3, it will be just moved to the right, pi over 3. But really, that will not have any impact on the maximum or minimum value of this function. So normally sine goes between -1 and 1, but when it's multiplied by root 15, the minimum and the maximum will be stretched to these values. So the maximum is root 15 and the minimum is minus root 15. Now you have been asked for that part to work out the smallest positive value of theta when this maximum or minimum occurs. So simply solve many equations. That will occur when root 15, which is your y function, will be made equal to minus root 15. So when you make y equal to minus that, so that means when you make sine equal to -1. So do the sine inverse of -1. So sine inverse of -1 is going to be minus pi over 2. That's the first time it happens, minus 90 degrees over here. So for this one, but it also happens for 3 pi over 2. So I'm considering these two. So theta is going to be, and it's a good job I did, because minus pi over 3 is minus 60 degrees, and minus pi over 2 is equal to minus 90 degrees. So if I add pi over 3 to rearrange it, to work out what theta is, look what happens. We've got turned it off, minus pi over 2, there you go, and then we're going to add pi over 3. That is giving me a negative value. That is not what the question asks you to find. It finds you the smallest positive value. So I need to consider the next one. So this is 3 over 2 pi. So if I just put quickly 1.5 pi. And then if I add pi over 3, so if I add pi over 3, I'm going to get 11 pi over 6. So this is going to be the first positive value for which the minimum occurs. Now, when will the maximum occur? You do exactly the same. You set your function equal to root 15. So that will happen when you make your sine equal to 1. So you could have just straight away made it equal to 1. Sine is always going to be equal to 1 when this is equal to pi over 2, and then again at 90 degrees more than 360, so this will be 5 pi over 2. But let's see if we do the first one first. So if you make it pi over 2, that will be enough, because if I add pi over 3 to this, so it's going to be a half plus a third, that's 5/6 of pi. There you go. So this is the answer when this maximum occurs. Now, for question II, over here, now we need to consider what is the maximum and the minimum value of this expression. So, what is the minimum first? So if I say y is equal to that. So the minimum of that is simply what would happen if I have this function. So let me just write it down. Let's just square it. So it's going to be, let's just write it like this actually. Okay, So if you think about it, what happens to a number that this f of x is normally at its maximum equal to root 15? So if you think about this one, root 15, if I square it, then I'm going to square that root 15. So the I'm talking about the maximum. So the maximum will happen when it's 15, okay? Because then you have sine squared, and sine squared at its maximum is the same as sine, which is 1. So it's 15 times 1. When does it happen? Well, for this one here, oh no, that was only for part I we had to answer. But for this one, this will happen when this one happened to be a maximum, so 5 pi over 6. Let's consider the minimum. So the mistake students make is by writing minus 15 here. But remember, this is a square. A square number cannot, when you square a result, you cannot get a negative answer. Anything squared at its lowest is equal to 0. So the minimum value of this function is 0 only. And if it asks you when it happens, you need to find when this is equal to 0. So you would do root 15 sine theta minus pi over 3. When is this equal to 0? So this is when sine theta minus pi over 3 is 0. And that means you've got, for sine graph happens at 0 and then pi. So theta, if you add pi over 3, will be pi over 3. And then add pi over 3 will be 4 pi over 3, but you only need to give one number. Okay, so let's, I needed another piece of paper. No, actually use this one and come back to this question afterwards. So let's do the part I. So this one is an awkward one. The reason I've included it here, because it has been asked 2 or 3 times in the last 5 years. So you could have a question like this. So they ask you to find the minimum maximum value of this expression. What I suggest you do, it's very simply think, what is the f max? And that was root 15. And what is the f min? And that was minus root 15. We found it in the first part. So just consider 2 values, 2 expressions, 1 over 5 plus whatever this one is at its maximum, and then 1 over 5 minus root 15, so you are adding minimum, and then put it into the calculator. So you're going to get 1 over, this one is going to be 5 plus root 15, so that gives me the answer of 0.112, and this one here, if I put minus, I'm going to get 0.887. Which one is bigger? This one. So that must be a maximum value, and that must be the minimum value, because these are the 2 bounds that I've put in. Remember from GCSE, when you worked out the limiting value, so the bounds you've put, when you divide by the bigger number, you get the smaller answer, and that's what you've done here. So to make this one into a bigger denominator, you had to add root 15. So clearly we're dividing 1 by the bigger number, so you get a smaller answer. And over here, when we took it away, we created a smaller denominator. When you divide by a smaller denominator, that grows bigger. So that one is the maximum. And the last one here, you've got this expression, 3 of f of x minus 7. So this is connected to transforming graphs. So if you have this function, really you just need to think, I need to transform the maximum and minimum value of y. So if you think about it, whatever your function is, it was the sine graph, I don't even need axes. Let's say the minimum value was at minus root 15 and the maximum value was at root 15. So if I stretch it by the factor of 3, I'll be stretching the graph like this by the factor of 3. So it is going to affect my maximum minimum. So you times that by 3. So that, and then you will shift everything 7 down. So we'll go down 7. So we'll be minusing everything by 7. So that one will remain the minimum. So y minimum is going to be minus 3 root 15 minus 7, and the maximum value will be 3 root 15 minus 7. There you go. Question 6, we have to prove this identity. So in the exam, I think in the test you had sine 3x, so here I've got cos 3x. This is the same trick. When you're doing the proof, you need to split 3x into 2x plus 1x. And then you're going to use cos A plus B addition formula, which is cos A cos B minus sine A sine B. But in this question, A is being replaced by 2x and B by x. So if you write this down, you will have cos 2x cos x minus sine 2x sine x. So that's your first mark. Okay, so starting with the left hand side, that's cos 3x. We are going to replace it with cos 2x plus x, and then you're going to write it as cos 2x cos x minus sine 2x sine x. And then you need to, because you are aiming to have everything in terms of single x's, that's the first thing you should be looking at. It doesn't matter that they are causes, I wouldn't worry about it yet. It's the fact that you don't have any multiples of x's. So I don't want that to cos 2x, and I don't want that sine 2x. So I need to get rid of them. Now cos 2x has 3 different guises. If you can only remember this one, just go for it. Let's use this one. Okay, so you could go for cos squared x minus sine squared x. If you remember that it can be written as 2 cos squared x minus 1, and you are 100% certain that is correct, then do that replacement, because you are aiming to get expression in terms of causes, so that would work. But I'm happy with that. So sine 2x is 2 sine x cos x. It's always a good idea to quote your formula on the side. Sine 2x is equal to 2 sine x cos x. And this here is going to be minus 2 sine squared x cos x. And this here, if I expand it, I will have cos cubed x minus sine squared x cos x. So what have I got? I've got cos cubed x, and I've got minus 3 sine squared x cos x. Have a glance at what you want. You want to have causes only. You don't want that sine squared. So you know that 1 is equal to sine squared x plus cos squared x. So the easy replacement for sine squared is 1 minus cos squared x. So you've got this expression instead. So you're almost at the end. Just expand this. So you've got cos cubed x minus 3 times cos x times 1. So it's minus 3 cos x minus 3 times cos x times minus cos squared will give me plus 3 cos cubed x. And finally, adding this and this together will generate 4 coses that are cubed, and then you still have minus 3 cos x, which is equal to right hand side as required. Right, moving on to question 7. That's another proof. So I always say to start with the busier side, and the side obviously has fractions, but to me the side that's busier, it's the one that has 2 theta, and you want to go to single theta. So we start with the left hand side. So I'm going to change this cos and sine into the single causes. So again, if you're not sure what to use here, I'll use cos squared theta minus sine squared theta. I've just used that one in the previous example, so I'm not going to write it on the side. There you go. So I've just copied the denominator and used the expansion of sine 2 theta. Now over here, I'm just thinking it's a good idea to have a look at what right hand side looks like in terms of sine and coses. So cot is cos over sine. So I'm thinking I want to have sine theta in the bottom of the fraction. So I want to keep this. I want to get rid of coses. The only way I'm going to get rid of coses if I've got some coses on the top to cancel it down with. So let's express the top in terms of cos only. So if you gather 1 and minus sine squared theta, this is equal to cos squared theta. So you've got cos squared theta plus another cos squared theta, so it's 2 cos squared theta over 2 sine theta cos theta. Cancel the 2's and cancel the coses. You're left with cos over sine, which gives me cot. Proven. Okay, last question. We are asked to write it in terms of r sine theta plus alpha. So the first thing I like to do is write this expansion using sine a plus b. So sine a plus b, you can glance in the formula booklet, but I'm sure you will know it by heart. Sine a gets together with cos b. Then you've got cos a gets together with sine b. So you've got the combination of all sine and coses of a and b. So let's write it down in terms of theta plus alpha and multiply both by r. So you will have r sine theta. So this is r sine theta plus alpha that I'm expanding. And then cos alpha. And then the second term will be multiplied by r to give me cos theta sine alpha. And then I'm going to make comparison with the expression above. So look for the terms with sine theta. So whatever it's multiplied by, these need to be equal to each other. There you go. So that tells me that r cos theta must be, r cos alpha, so it sounded wrong, is equal to 10. So I sometimes like to cross it off like this. I'm going for the second one. If you go for the cos theta, so that one here, if you compare the 24 with r sine alpha, so you've got r sine alpha is equal to 24. So from this, you always use Pythagoras, squaring these together and adding always those coefficients. That will give me the value of r. So it's going to be, I think it's going to Pythagorean triple 26. There you go. And we have to find the value of alpha. So the best way to do it is to divide sine by cos. R's will cancel. So if you divide this one by that, so sine alpha over cos alpha will give me tan alpha. So that will be 24 over 10. So alpha is equal to tan inverse 24 over 10. Not sure whether we are in degrees or radians. Let me just double check. So we got it right. Looks like we are in radians. So I need to just do that in a second. I'll do it in degrees and then convert it. Okay, so 67.38 degrees. I'm going to times it by pi and divide it by 180 to give me alpha is 1.176 to 4 significant figures. So the answer would be 26 sine theta plus 1.176. So this here is a replacement for this function. So this is your f of theta. It's not exactly equal to f of theta because you approximated the angle here, but it's close enough. Okay, so now you can have a go at the remaining questions. Just decided to add one more question to the worksheet. it's on finding the Cartesian equation of a parametrically defined curve. X equals to cos theta, y equals to tan squared theta. So over here we need to find, when the functions are defined in terms of trig function, you need to find the identities that you can use where cos and tan are connected. So one identity is the fact that tan squared, I mean there's more than one, but you could think of tan squared theta, so 1 plus tan squared theta actually is equal to sec squared theta. So, but you might say, well, okay, well I've got tan squared, but where is sec? Well, sec squared is equal to 1 over cos squared theta. So really, over here, we can substitute these into the identity. So instead of tan squared, I can replace it with y. And instead of cos here, I can replace that with x. So I will have 1 plus y equals to 1 over x squared. Now clearly we want to make y the subject in this question, so 1 over x squared minus 1, and you are done. There you go. If the that's it.